Hi everyone. We discussed regarding the matplot library in the last video, and I just want to take that conversation discussion ahead with some of the visualization which are available in Pandas and also to introduce the Seaborn library. So if you don't already have the Seaborn, you can use the pip install Seaborn, and I'm going to load the libraries, the Pandas, the NumPy, the Matplotlib, and the Seaborn. As I told, when we use the dot plot, the default graph which is there in the in the visualization is a line chart, but you can change. You can use a bar, you can choose the histogram or other different type of plottings. So let's see what the line plots looks like. And in this, I'm going to create the series of the random number from standard normal distribution. Then and doing the cumulative summation of that. Also, the index is 0 to 100, but with a step value of 10, so it will like 0, 10, 20. And if you want to see what's the series look like, and it's like it's 0, 10, 20 is the index, and these are the values. And if you just directly do the s dot plot, what it will do, it will create the line plot. You see, so index is nothing but these values, right? 0 to 100, 90, and the values, whatever value is there, it's just been plotted here like this. What about the data frame? So similar concept is will be applicable in the data frames too. So let's create the 10 by 4 matrix with the cumulative sum. 0 represents it will do the cumulative sum of the rows, right? Index is again same and the column represent A, B, C, D. So this is what the data looks like. And what we are going to do, let's do the data frame dot plot. So for each column, right, for each column A, B, C, D, it just created a line, right? As I told, line is the default for the plot function. And you can use the different styles. There are different styles are available. Like in this case, let's use the grayscale plt dot style reduce and then now plot it. So it will be different plot from the previous one. Let's look at the bar plot. So bar plots are of two types. You can have the horizontal bar or the verticals. For the vertical, you can use .bar, right? And for the horizontal, you have to use barh. So in this way, I'm creating the two rows, one column subplot. This is a series of size 16, and the list is A, B, C, D. So these are will be the index. And doing the bar plot data. So whatever data we're doing plot dot bar on the first axis. So as I told, there are two rows and this will be the second. So let's see what the results look like. So the first one is the bar, the normal one. It is a vertical, right? And if you want horizontal, you can have BARH on the same data, same values, right? You see ABCD on the for the verticals, right? On the x-axis, now the x-axis has been converted into the y-axis. Let's create one more data frame in this. It's 6 by 4 matrix. The index are 1 to 6, and this is a column A, B, C, D, right? For columns, and we have also added the legend. Legend is nothing but the name of the column. And if you do the df dot bar, it will be for each value, for each index value, there are four values, right? So bar plot will be plotted here. And the legend are these are the columns. For each column, the values each row, and for each column the single bar is being plotted here. Similarly, if you do .barh, same thing will be converted into horizontal bar. But if you type the stack true, so what will happen, instead of creating a separate bar, it will stack into the single one, means each column, each row value for each index will be stacked into the one bar. We can take one example here. Have a CSV file which consists of the tips. And let's see the data. So it has the this column, the total bills, the tip given, who is the person, male, female, is the smoker, what is the day, it's Monday to Sunday, and what is the timing, and what is the size, how many persons are there. So what we are going to do, we are going to use the pd.cross tab on the day, on this, and on the size, on which day, what is the size of, means how many number of peoples are there on the party count. So what it will do, it will create a cross tab, means on Friday for one side the value is 1, and from Friday you can see the two peoples are total count is 16, and Thursday we have like this. And we can do the re-indexing of Thursday, Friday, Saturday, Sunday, right? In this order, same values, just we create a new index. Next, because the value 1 and 6, it does not have a significant number, so we can remove those. So all the rows 2 to 5, 2 to 5 will be there, right? And now, instead of using the numbers, what we will do, we are going to normalize, which will all the summation is going to 1. So what you can do, the party count dot div, and the count of the summation of all the x of the column, and index will be, axis will be the index. So these Thursday, Friday, Saturday, if you do the sum, so it will be the value 1. Okay. Normalizing is basically used in the machine learning, also, which we'll discuss when we deep down into the machine learning topics. So let's plot this. So we have this percentage, right? Plot, and we are going to the bar. So for each index, there are four values. For each index, there are four values that been plotted here. And you can do the stack bar, right? And to get the insight, you can see on the Thursday, Friday, Saturday, Sunday, the size of people is more, right? And that makes sense. So there are on Saturday, Sunday, there are the size is increased, right? The number of people is been increased because of the weekends. We can also collect the tip percentage. So tip divided by total B minus tip. And this is the value. We are just creating a new column. This is a 6% tip here, right? And yeah, 19%. Likewise, you can do the bar plot for the tips, right? For Sunday, you can see the tip is more compared to the other. And you can also add the timings, right? Whether it's a dinner time or the lunch time. So that's being added here using the hue argument. And also, we can also create the histogram and density. Let's look. So histogram, you divide your discrete data into the bins, and in this case, we are going to use the tip percentage. We are going to close and be the histogram and the bins of 50. So in the bins of 50, it says divide the value and represent. This is the percentage of the tip, and you can see this is a frequency compared to the percentage. Density is very similar to this histogram. For use to use this plot or density, you need to install the SciPy if you don't already have. And this is again the same thing, representing of histogram into the one singular chart called the density. So it shows the where are the most values are situated. Let's create it to standard normal values to 100, and this is the second, and we are just concatenating, means we are just adding and creating a single series. And let's single series, we are going to do the his plot for bins 100. So you clearly see this is a comp 1 and this is a comp 2, right? Next we have the scatter plot. So scatter plot is we have the values, right? We have a data called macro data, and these are the columns in that. I'm just removing the unwanted columns here, keeping in data, making it into logarithmic, and if any values are there, it's going to drop there. Let's see how the data looks like, right? And let's plot the regression plot for this. So now, interestingly, I have start using the Seaborn, so as you can see, SNS.regplot, and while using that, you have to provide three arguments that are mandatory: the X value, so M1 is the X value, unemployment is the Y values, data which are using the trans data which we created here, and that's what it also shows the regression line which fits in this data, and as you clearly see, it's very scattered, right? And if you want to see the if you want to plot all the columns in the data, you can use the pair plot to see different kind of data. Let's plot that pair plot, and you will see the densities compared to what it will do. It will compare the data, so CPI with CPI, right? And you can also see diagonally how the data is being scattered, or if there are any relationship, if there is a correlation, right? If there is a negative correlation, positive correlation, you can identify using the pair plot. There are many arguments available to explore on this one. We have a facet grid for the categorical data. So if you have a categorical data, in this case, we have the date, tip percentage, and smokers, right? And smoker was the one. Let's see how the results look like. So what we are doing, we are dividing based on the time, right? And also the column smoker. So smoker is no, smoker is yes, and time of the date. That's how data is being divided. Here we are dividing also based on the time and the smokers, right? Time and the smoker. So if it is time is decor, smoker no, time is dinner, smoker yes, time is lunch, smoker yes, right? So you get a lot of insights based on your data sets. And the last one is just a box plot. So I'm using the cat plot and the kind is box. So earlier the kind was bar, right? So it's going to bar plot. And this is the box plot, which these are the outliers and this is the median value. This divide the box plot divides your data into four quartile, 25%, 50%, right? 75%, like that. So this is a very basic introduction of the Seaborn and the pandas inbuilt available plottings, and also we discuss on the matplotlib. So this give you the very basic understanding of how to use your data, how to plot them, and start developing and getting some basic insight from the data. Thank you.